Oh, hey, you've met my friend Labbit. Labbit and I are going to teach you about insulation. Not insulation like the pink fiberglass stuff in your attic. We're going to learn about insulation spelled with an O, which is short, I guess it's short, for incoming solar radiation. It's the amount of sunshine we get. Now, the amount of sunshine we get is affected by three main factors. The first would be the reflectivity of the atmosphere and the ground. The second would be the angle of the sun. And the third would be the duration or length of time that the sun is shining. We're going to start with angle of insolation. Now, the angle is affected by three main things. The first one would be your latitude. Labbit. What latitude gets the most sun? The equator. That's right. Very good, Labbit. The equator gets the most sun, or the highest angle of insolation. We live at the mid-latitudes, we get a medium amount of sun, and at the North and the South Pole, which are the highest latitudes, they get the least amount of insolation because that angle is spreading out the amount of radiation. The next thing that affects angle of insolation is season. Labbit, what season do we get the most sun? Summer. Very good, Labbit. Summer in the northern hemisphere occurs, well, the first day of summer is June 22nd, June 21st, that range. But generally, climatologically, we consider June, July, and August to be the summer, and that would be when we get the most sun. In the northern hemisphere, our winter, which begins on December 22nd, is generally considered to be December, January, and February. Is that the same in the southern hemisphere? No, it's not. Because of the tilt of the Earth, the southern hemisphere has the opposite seasons, and therefore they are getting the least amount of sun when we're getting the most, and vice versa. The next thing that affects angle of insolation would be the time of day. How many of you have tried to get a suntan at 6 o'clock in the evening? Doesn't work. When's the best time to get sunburn, skin cancer? Noon. Well, specifically solar noon, which is the time the sun is at its highest point in the sky on any given day. Now that changes based on your longitude, and that changes based on daylight savings time. The sun, when it's the highest in the sky at 12 o'clock, that was when you get the highest angle of insolation, and obviously in the morning and the evening you get the lowest angle of insolation. Next thing we're going to talk about, duration of insolation. Duration means how long is the sun out. Now it just so happens that duration corresponds exactly to angle. Labbit, what day of the year is the longest day of the year? The first day of summer. Very good, Labbit. So on June 22nd, which is our first day of summer, we have the longest day of the year, and we also have the highest angle of insolation. So those correspond to give us the warmest temperatures in the summer and our coolest temperatures in the winter. What it says over there. This is a comparison of the path of the sun. Now, obviously, you guys know that the sun isn't really moving through the sky. We're going to call this the apparent path of the sun through the sky because we know it's actually the Earth rotating, not the sun moving through the sky. Now, the higher one would be the apparent path of the sun in the summertime, and the lower one would be in the wintertime. You'll notice, first of all, that the sun is rising much further north and setting much further north and arriving at noon at a much higher point in the sky in the summer. In the winter, it rises further to the south, it sets further to the south, and it has a higher angle of insolation at noon, lower angle of insolation at noon. I know what I'm talking about. Third one, reflectivity. Another word for reflectivity is albedo. I love that word. When I was in college, we did an albedo lab where we had to go out and spread ash on little blocks of snow in the wintertime and then measure how quickly the snow melted. Ever since then, I've been in love with the word albedo. The sunlight is reflected by the top of the atmosphere, it's reflected by the clouds, and it's reflected by the surface of the Earth. Light-colored things and shiny things are going to reflect more radiation, so they're said to have a high albedo. Dark-colored things and rough surfaces are going to absorb more radiation or reflect less, and they have a low albedo. What's going to have the highest albedo? Snow, a plowed field, sand, or the forest? Snow, obviously. And that is why when you have snow cover in the winter, it makes it even colder because more radiation is getting reflected out into space. When we talk about global climate change, that's going to be key because the less snow and ice cover you have, the more radiation gets absorbed and the warmer the atmosphere gets. We'll go down the list and look at them all. Now, sand also, surprisingly, has a fairly high albedo. Now, you wouldn't know that if you go to the beach and you're walking on the beach in summertime, it gets real hot, you burn your feet, and you think, this is absorbing a lot of radiation, and it's true. But if you look at the sand real close, you'll see there's dark particles and light particles, and the dark particles are absorbing, the light particles are doing the reflecting. Now, forest and plowed fields absorb the most radiation. Forest, surprisingly, would be the most absorbing. It's not a coincidence that leaves are green. They're green because they do the best, that would be the best color for absorbing radiation from the sun. Now this is an overall map with numbers of how energy from the sun is parsed when it comes to the Earth. So you see that up here we'll start with 100 units of whatever radiation it might be. Initially, 8 of those units get reflected by the top of the atmosphere. Another 17 of those units get reflected by the clouds back out into space, and another 6 units are reflected by the Earth back out into space. Of the remaining 100, 19 get absorbed in the middle of the atmosphere, in the stratosphere, by ozone, water vapor, etc. Another 4 units would be absorbed by clouds, and 46, or just under half of all the energy reaching the top of the atmosphere, just under half actually gets absorbed by the Earth. Now if we go to the right side of the screen, now we're talking about the radiation being emitted by the Earth. We'll talk about that another time on a day when we talk about greenhouse effect. I'm all done. If you have any questions, please write them down on your paper and we will discuss it in class. I'll see you tomorrow.